Dear students, we now discuss linear differential equations. An nth order linear differential equation is an equation of the form p0 of x into nth order derivative of function y with respect to x plus p1 of x into n minus 1 order derivative of y plus and so on plus Pn minus 1 of x into dy by dx plus Pn of x into y equal to g of x. Here we assume that the functions p0 of x, p1 of x and so on, Pn of x and g, all these are real valued functions. These are continuous functions defined on some interval, open interval alpha beta. We call this interval as I. Further, we assume that the leading coefficient, that is the function p0 of x, is non-zero on this interval, so that we can divide by p0 of x and get simpler equation, say yn. Okay, here we introduce new notation for derivative. So this yn, if we are using bracket, then it is nth order derivative. Okay, so this, if we write y2, then this is y square. Okay, instead if we use y, this bracket 2 means it is second order derivative of y. Okay, so if there is bracket, it is derivative, otherwise it is power. So this equation becomes, we are dividing by p0 of x, so first term is nth derivative of y plus second term is p1 divided by p0. P1 divided by p0, we write it as small letter p1. Okay, so small p1 of x, yn minus 1 plus and so on. Then we have coefficient of y dash, that is dy by dx. It will be Pn minus 1 of x divided by p0 of x, which we call small letter p sub n minus 1 of x, and last will be Pn of x equal to small g of x. Small g is capital Z divided by p0. Okay, so this is equation 2. Now we define operator L by L of y equal to left hand side of equation 2, that is L of y equal to nth derivative of y plus p1 of x y n minus 1 plus and so on Pn minus 1 of x y dash plus Pn of x y. Okay, so the equation 2 can be written as L of y equal to g of x. Okay, so this is compact form of equation 2, L of y equal to g of x. Now there are some important remarks. First thing is, L is a linear operator. Okay, we know that derivative is linear operator. What is mean by linear operator? It means if we consider a linear combination of this form, c1 into y1 of x plus c2 into y2 of x, and operate L on this, then we get c1 into L of y1 of x plus c2 into L of y2 of x for all constants c1, c2 and functions y1, y2. This is because it is the derivative is linear operator. Okay, we know that if we take d by dx of this term c1 y1 of x plus c2 y2 of x, then it will be c1 into y1 dash plus c2 into y2 dash. Okay, same thing is true with second order derivative. Okay, so second order derivative of c1 y1 plus c2 y2 is c1 into y1 double dash plus c2 into y2 double dash, and so on. Second point is, if the functions p1, p2 and so on, pn are constants. Okay, so we know that constant functions, these are continuous functions. We can take all these coefficients as constants. Then the differential equation 2 is called as constant coefficient equation. If not all these coefficients are constant, then we call the differential equation as variable coefficient equation. Third point, if right hand side is identically 0, that is function g of x is 0 for all x in the interval I, then the differential equation 2, it will be L of y equal to 0, and this equation L of y equal to 0 is called homogeneous differential equation. If g of x is not identically 0 on I, then this equation is called as non-homogeneous differential equation. Remember that similar terminology is used in first order differential equations, where we consider dy by dx equal to ratio of two functions, say f of xy upon g of xy. F and g both are homogeneous functions. Okay, in that case we call the differential equation as homogeneous differential equation. Here term is same but thing is different. Here homogeneous linear differential equation means right hand side is 0, that means the terms are only for y, y dash and so on, nth derivative of y. Okay, so no any other term is there, so it is homogeneous differential equation L of y equal to 0. Next point, fourth, the differential equation 2 is nth order differential equation. So we know that the general solution should contain n arbitrary constants, say c1, c2 and so on, cn. Now we can have any value for such arbitrary constant. That means we don't have unique solution, we have infinitely many solutions. So for uniqueness there should be some condition. Okay, so we have to specify n number of conditions at some point. Say y of x0 is y0, y dash of x0 is y0 dash. Remember that this y0 dash is not the derivative, it is certain constant. Okay, for example, y dash of x0 equal to 3. Okay, and so on. Yn minus 1 of x0 is y0 n minus 1, yn of x0 is y0 n. So all these conditions are at some point x0 in the interval I. So this set of initial conditions is called as initial values. Okay, the differential equation L of y equal to g of x along with all these conditions is called as initial value problem, IVP. Now important result is existence and uniqueness theorem. If the functions p1, p2 and so on, pn and g are continuous on the open interval I, then there exists exactly one solution to the differential equation 2, that is L of y equal to g of x, satisfying the initial conditions. Okay, so this is important result. The condition is continuity of all the coefficients and the right hand side function g. If this condition is satisfied, then this initial value problem has solution. Moreover, the solution is unique. This solution exists throughout the interval I. Okay, the same interval where the functions pi's and g are continuous. So what is the meaning of this result? First thing is the initial value problem given by differential equation 2 and conditions 3 has a solution. That means a solution exists. Second thing is the IVP has only one solution. That means uniqueness. And third thing is the solution is defined throughout the interval I. Okay. And what is meant by solution? Solution means it should satisfy given differential equation, and given differential equation contains the derivatives up to order n. That means the solution is n times differentiable in the interval I. In the next lecture, we discuss the superposition principle of the solutions for homogeneous equations. Thank you.